Question 93, static friction. A 20-pound box sits at rest on a horizontal surface, and there is friction between the box and the surface. One side of the surface is raised slowly to create a ramp. The friction force F opposes the direction of motion and is proportional to the normal force exerted by the surface on the box. The proportionality constant is called the coefficient of friction. When the angle of the ramp theta reaches 20 degrees, the box begins to slide. Find the value of the coefficient to 2 decimal places. First, I want to talk about this illustration I drew over here, that I color-coded the vectors, and I'll just label them right now. That this is F of n, this is the normal force, here is friction, and here is the gravitational force. I'll say F of g. Actually, to make this look better, I'm just going to make this F of g, gravitational force. And since our object is on a ramp, that this gravitational force, we can break it down into components. That this gravitational force, this vector right here, can be broken down that you can find the vector that's, or the component that is perpendicular to the ramp. Let me change this to orange so it makes sense. And then the next one is parallel to the ramp. To dissect this question, I want to go back to the question here that I've highlighted. The first one I highlighted was a 20-pound box is at rest, meaning that the box is stationary. It's not moving. This box is not moving, which means that the sum of the forces equal 0. That whatever this force, which right here, if I look at my illustration, the force, the gravitational force that is parallel to the ramp is the one that is opposing the force of friction. It's going in the opposite direction. Since the box is at rest, that means those two forces equal 0. They're going to cancel each other out because it's keeping the box at rest. And we also know that normal force is going to equal the gravitational force that's perpendicular to the ramp. And the second part that I highlighted was opposes the direction of motion and is proportional to the normal force. And what that means is right here, this equation, that it is the ratio of friction divided by normal force that's pushing the objects together. Now we just need to find friction and normal force. And just what I was talking about, that friction equals the parallel component of the gravitational force, and that's how we'll find friction. And same for normal force. Finding the perpendicular component of the gravitational force is normal force. So whatever this is normal force, and whatever this is friction. So I can put that out here right now, that we'll say the force of gravity, which is perpendicular, equals normal force. And F of g, that is parallel to the ramp, equals, well, first let me do, as you can tell, the friction is going in the negative direction. So it's minus F, right? Equals 0. But we're trying to find, this is how you would set it up, and then plus F to the other side. Then you know that these equal each other. I'm just going to erase all of this. Then how do we find this side and this side? Well, we know that theta equals 20 degrees because it says that that when the angle of the ramp theta reaches 20 degrees, the box begins to slide. So that is right when we go from static friction to kinetic friction. And it's right at that point where the box is at rest before it begins to slide down. This is when geometry comes into play. Where would theta be in this triangle here? Because if you say theta would be right here, you would be incorrect. Which I think this part is always a little confusing on understanding where theta is. Where is the 20 degrees? Now, if you want to memorize this, you always put the angle of inclination at the tail end, meaning the tail of these vectors. Right at this point, gravitational force, the tail is right here. So the angle of inclination is always going to be put at the tail then. And just by memorizing that, you will know to put theta over here. Another way of doing this is understanding complementary angles. That with two parallel lines are intersected by the transversal line, it forms two congruent angles. Now, if I drew a parallel line with the horizontal, with the x-axis, so I draw it right here. I'm just going to change the color of black to match down here. So when these two parallel lines right here and right here, the transversal, which I will color code this so it's easier to see, the transversal will be in purple. Now, as you can see, this transversal created two congruent triangles, one right here and one right here. That this angle is the same as this angle. This forms a right triangle because this is perpendicular to the ramp. See, it's getting a little messy, but this purple line, right, is the ramp, and it's perpendicular, forming that straight line. And then you have the parallel line. You have the line of the ramp going down. That means this angle, theta, will be right here at the tail of the vectors. Once we have that, then we can find the gravitational components. Since theta is right here now, we find opposite over, since this is a right triangle, over hypotenuse. And we know theta is 20 degrees. So that is, and we also know the hypotenuse is 20 pounds. It's going to be a little confusing with 20 and 20. But so 20 times sine 20 degrees, that will be for the gravity that is parallel. That means this will be divided by the normal force down here. We just do the same. We do the cosine now. We do adjacent over hypotenuse, which would give you 20 times cosine 20 degrees. That is gravity perpendicular to the ramp. So you see this and this. Now the values you get here should be 6.84 over 18.79, which would be 0.36 as the coefficient of friction. And this is dimensionless. We just say 0.36. And the coefficient, its value is between 0 and 1, but it can be greater than 1. If it was instead of 0.36, if it was just 0, that means there is no friction between the two objects, between the box and the ramp. But since in the problem it said there is friction, then we do have friction. We have 0.36. And it could be, I don't know, it could be a wooden box on a wooden ramp. They don't give us any context on that. So we don't know the material. To prove this is the correct answer, what you can do also, and is why I put this here, the identities, is that what we have, right, was f of g sine, which is friction, theta, over f of g cosine theta. And we know that the coefficient equals this. What we can do is we can cancel f of g out. So we just have sine theta over cosine theta. And that identity is tangent theta. And we know theta is 20 degrees. So if you put 20 degrees in here, this would equal 0.36. Just to show proof that that is the correct answer. I hope this was helpful.